Assalamu alaikum, hello and welcome back. Today we are going to solve a numerical problem from the F.Sc Chemistry Part 1, Chapter number 1. This numerical problem is going to be from the exercise, and the question is question number 11. So let's just see that what this problem is. Alright, let's see this statement of this problem. Okay, a sample of the statement of this problem is a sample of 0.6 moles of metal M reacts completely with the excess of fluorine to form 46.8 grams of MF2. The part 1 of this problem is how many moles of fluorine are present in the sample MF2 that forms. So first thing we need to determine is that number of moles of fluorine which are present in MF2, the product MF2. And secondly, we are asked to determine that which element is represented by the symbol M. That is, here the M represents a supposed metal. We need to know what this M represent. What does this M represent? All right, let's just move ahead and see that. Okay, firstly we are going to solve this part A, that is how many moles of fluorine are present in the sample MF2. So I'm going to write it down over here, that is number of moles of fluorine in MF2. So before moving on, we need to know a very something we are going to use in this numerical, and let's just see that what this is. I'm going to just write down a chemical formula of some form of any molecule, say glucose. We know that the glucose has a molecular formula of C6H12 and O6. What if I write down 1 over here, which you usually encounter in while you are you have some chemical equation? So what does this 1 represent? This can represent two things. Number 1 is molecule, and secondly it could be mole. If this is a molecule, then what? If this 1 represents a molecule, then it means you have 6 atoms of carbon and 12 atoms of hydrogen. Similarly, you have 6 atoms of oxygen. And what if this one is representing as is mole? So this means that you have 6 mole of carbon, 12 mole of hydrogen, and the same way you are having 6 mole of oxygen. Sorry, we're going to use this concept during the while solving this numerical problem. Alright, the first part of this numerical problem will be, that is how many moles of fluorine are present in sample in the compound MF2. So in order to determine the number of moles of fluorine, we need to know the number of moles of MF2. So this is going to be the first part actually. To determine the number of moles of fluorine, we need to know the number of mole of MF2. For this purpose, let me just write down a supposed chemical equation. Why I'm saying that supposed chemical equation? Because we still do not know what actually the metal M represents. Supposed balanced chemical equation. Okay, we are told we have metal M. It is reacting with fluorine, that is a diatomic homonuclear molecule, and we're having compound that is actually MF2. You can see that this equation is already balanced. 1 mole of metal M is reacting in 1 mole of fluorine and producing 1 mole of MF2. In order to determine that is how many moles of MF2 can be produced from this metal M, we need to know the concept of limiting reactant and excess reactant. We are told that the fluorine is in excess. Fluorine is in excess. You can see that completely from this statement. A sample of 0.6 moles of metal M reacts completely with the excess of fluorine. So fluorine is in excess. That is, if reactant is in excess, it does not actually control the amount of products. So let me just write it down. It is in excess. So how many moles of MF2 will be produced are not dependent on fluorine because it is in excess. You can see that we are told that we have 0.6 moles of metal M. So this metal M, which is 0.6 mole in number, is actually the reactant that we will call as the limiting reactant. Why it is called as a limiting reactant? Because it is in limited amount, and the thing that is in limited amount actually determines that how many products will be formed. So this 0.6 mole of metal M will determine that how many moles of MF2 can we have. And how to determine that? For this purpose we need to make a comparison between the metal M and the compound MF2. So let's just make a comparison. The metal M and the compound MF2. From this balanced chemical equation you can see that 1 mole of the metal M produces only 1 mole of compound MF2. Let me just put it down over here. But we are told we are having only 0.6 mole of metal M. So how many moles would then be produced? Then 0.6 mole will be produced. If 1 mole produces 1 mole, then if you have 0.6 mole, it will produce only 0.6 mole. So this implies that we will be having only 0.6 mole of MF2 from 0.6 mole of metal M. Alright, this is the first thing we have just solved down, that is we'll be having 0.6 mole of compound MF2. From this 0.6 mole of MF2 we can determine the number of moles of fluorine present in it. And for this purpose we are going to use this concept which I just told you in the beginning of this lecture. Okay, let's just move on and see that how can we determine the number of moles of fluorine. Okay, let's just see that. Let me just write down MF2 over here. If I say I am having 1 mole of MF2, then this implies that I will be having 2 mole of fluorine. If I have 1 mole of MF2, then it would contain 2 mole of fluorine. But what if but we are given only 0.6 mole of MF2. This means that we can have 0.6 into 2 mole of fluorine. The answer comes out to be 1.2 mole. So we have solved down the first part of this numerical, that is how many moles of fluorine will be present in this compound MF2. So the answer for the first part is there will be 1.2 mole of fluorine. Alright, let's just see that what is the next part of this numerical. Which element is represented by the symbol M? So let's just solve it. Determine that. Let's just see that what is the symbol. What does this symbol M represent? Alright, let's just solve the second part of this numerical, which is the element represented by the metal symbol M. For this purpose, we need a very brief concept of two things. Number one is the molecular mass. The molecular mass of a substance is equal to the sum of all individual atomic masses. The second thing we are going to use, the second concept we are going to use, how can we identify an element? How to identify an element? So an element can be identified by two of its properties. One is the atomic number, which is also called as the proton number, and the other one is the mass number, that is also called as the atomic mass. So here we are going to use the mass number in order to determine the metal M. Alright, what I'm going to do here, I'm going to determine the molecular mass of the MF2 from the formula, that is moles are equal to mass divided by molar mass or the molecular mass. After that, I'm going to determine the atomic mass or the mass number of metal M. From this concept, that is the molecular mass is equal to sum of all atomic masses. And having done that, I will identify the metal M. Identify the metal M from its mass number. For this purpose, we will use the periodic table. Okay, let's just move ahead and see how can we do that. The first part is molecular mass of the compound MF2. For this purpose, I need to rearrange this formula, that is moles are equal to mass over molar mass, because I want to determine the molecular mass. So let me just this molar mass can also be termed as here for this purpose the molecular mass. So let me just put down molecular mass will be equal to the mass of the substance divided by the number of moles. And why are we doing that? Because we were given the mass of the substance of this MF2. It said that we're having 4.68 grams of MF2. So I'm going to use this 4.68 grams of MF2 in this formula. And the second thing is number of moles, and we have determined the number of moles of MF2 from the first part. Number of moles of MF2 will be 0.6. Here we solved it down. .6 mole. So let's just solve it. Molecular mass of MF2 will be 46.8 divided by its number of moles, and let's just solve it here. 46.8 divided by 0.6, and the answer comes out to be 78. So 78 will be the molecular mass of this compound MF2. Now what we are going to use from this, this 78 AMU, the second part, mass number of the metal M, and in order to determine the mass number of metal M, we need to use this molecular mass is equal to sum of all individual atomic masses. So let's just see that how can we do this. Alright, so molecular mass of MF2 is, let me just put it down, molecular mass is equal to sum of atomic masses or mass numbers. So 78 is the molecular mass of MF2, and we still do not know the mass. We are determining the mass of metal M. So sum of this mass metal M with the mass of fluorine, and the atomic mass of fluorine is 19, and we have 2 over here, you can see that. So 19 into 2 comes out to be 38. So let's just rearrange it. So M will be equal to 78 minus 38 is equal to M, and M is the mass of metal M. So the answer comes out to be 78 minus 38 comes out to be 40. So this is the mass of metal, atomic mass of metal M. So we have determined the atomic mass of metal M, that is the second part of this. Now what we are going to do, we are going to determine the we are going to identify the metal M from this atomic mass, and for this purpose we are going to need the help of periodic table. Alright, you can see that 40 is a mass number of calcium, 20 is its atomic number, and 40 is its mass number. So we have determined the metal M. It is actually metal M, the symbol M represents calcium. So the compound MF2 is actually CaF2. So we have solved down the second part of this numerical problem, question number 11 from the F.Sc Part 1 Chemistry. I hope you understood what I was trying to tell you. If there are any queries, you can put down your question in the comment box, and also do not forget to subscribe the channel, and also turn on the notification for the more movies and questions coming here. Thank you. See you.